Certified Lean Six Sigma Green Belt is known to be the first level of formal training. This can be taken by those professionals who know the foundational elements of the Lean Six Sigma methodology, who lead improvement projects. The demand for these professionals is growing by leaps and bounds, so if you guys want to be one among them, taking the Six Sigma Green Belt training is required. So, today let us discuss the same. Thus, today's topic is Six Sigma Green Belt Certification Training. Hello everyone, this is George from Invensis Learning. Welcome to our YouTube channel. Let us start our training video. Let us start our discussion by talking about Six Sigma. Then, we shall speak about Lean, and continue to understand 8 types of Lean. Then, let us combine Lean and Six Sigma to know about Lean Six Sigma. Then, let us point out some of the advantages of Lean Six Sigma, and continue to know different levels of Six Sigma. Soon after this, we shall dive into our main topic Lean Six Sigma Green Belt. Then to know more about these professionals, let us see their responsibilities. Then, we shall see who can take up this certification. Then, let us focus on the Six Sigma Green Belt course by Invensis Learning. Then, we shall see the benefits of taking the Six Sigma Green Belt certification, and continue to learn how to take up this certificate. Lastly, we shall see the main topics covered in this training by discussing the define, measure, analysis, improve, and control phases. Let us start the discussion by knowing what is Six Sigma. Introduction to Six Sigma. When coming to improve the businesses effectively and efficiently, Six Sigma ranks among the other methodologies. Upon that, it is a culture that everyone in the organization tries to implement. This method helps the organization by identifying the root causes of errors, for creating a better product and service for consumers. Six Sigma is a method of providing organizations a set of tools that helps in improving the success of their company. It is a disciplined, data-driven approach and methodology that usually aims for eliminating defects in any process ranging from manufacturing to transactional and also from product to service. In general, it means a measure of quality that strives for near perfection. It also has a generic or customized name for the organization like Operational Excellence, Zero Defects, or Customer Perfection. After knowing Six Sigma, it is very evident to know Lean, so now let us focus on what is Lean. Introduction to Lean. An organization that has implemented Lean understands customer value and focuses its key processes to continuously increase it. They mainly aim to provide perfect value to the customer through a perfect value creation process with minimal waste. Lean is defined as a set of management practices to improve efficiency and effectiveness by eliminating waste. The core principle of Lean is to reduce and eliminate wastes, that is, non-value-adding activities. This mainly aims at maximizing customer value while minimizing waste. To explain in simpler words, Lean means creating more value for customers with fewer resources. Lean is a philosophical way of working. Core to this philosophy involves the principle that expenditure of resources for any goal other than the creation of value for the end customer is wasteful and therefore should be a target for elimination. This principle is applied from the perspective of the customer who consumes a product or service. After getting an idea about what Lean is, let us take a look into different types of wastes that can occur in any Lean manufacturing system. 8 Lean wastes. Huge amounts of waste can occur in the workplace, particularly in the manufacturing process. Eliminating waste along entire value streams, instead of at isolated points, creates processes that need less human effort, less space, less capital, and less time to make products and services at far fewer costs and with much fewer defects, compared with traditional business systems. But do you know what the 8 most common wastes are and how they impact your organization? Taiichi Ohno, who is popularly known as the father of the Toyota production system, created a Lean manufacturing framework. This was purely based on the idea of preserving value with less work. Anything that does not increase value in the eye of the customer must be considered waste, or muda, and every effort should be made to eliminate those wastes. There are 8 waste points which are abbreviated as. Let us understand each of them in detail. The first waste found is defects. Defects may be incomplete or inaccurate products, services, or information. Because of this, products or services fail, and it requires rework, review or retesting. Time and cost resources get wasted due to this. One way to get rid of this is to have clear operating procedures or specifications or try to improve quality assurance steps by utilizing automated systems or any other new technologies. The next one is overproduction. Overproduction means making something, like products earlier or faster than needed or manufacturing more products than what is required. Some of them would be raw materials that are not required, work in progress, or finished goods without having adequate demand in the market. The best way to get rid of this waste would be by reducing large batches, building trusted supplier relationships, using value stream mapping, process mapping, and other good analytical tools. Then, we have waiting. Waiting is that idle time while waiting for materials, equipment, parts, people, or information. Machine downtime, system downtime, slow system response time, waiting on approvals, waiting for material from vendors or for information from customers are all included under this type of wastes. The solutions that could help them to remove this waste would be to utilize planning and scheduling solutions for better timing, upgrade systems to present trends. Use CRM and ERP software for streamlined flow of data and better communication. Next in the list, we have non-utilized talent. Non-utilized talent is the experience, skills, knowledge, or creativity of your team that is not used to the full extent. Like, the employees not listening to team members' improvement suggestions, or not recognizing employee contributions, strengths, and talents. To eliminate this, encourage employee suggestions, provide cross-training, form worker teams to solve problems, encourage employees to take ownership of their processes that can promote involvement. The next type of waste is transportation excess. Transportation excess is the unnecessary movement of products, equipment, or materials that have been manufactured excessively. The main reason for this is poor layouts that require extra forklift movement, or maybe the multiple storage locations cause excess transportation of materials. One method to eliminate this waste is by reducing distances items must travel, and addressing space issues by using process maps. The next one is inventory excess. Inventory excess is the overaccumulation of stock beyond what is necessary to serve the customer. Some of the examples of this type of waste include stock and work in a process that exceeds what is necessary for just-in-time or excess inventory buildup. One better way is to utilize an inventory management system for better coordination, planning, and reduction of inventory, set purchasing rules, use FIFO to reduce obsolescence. Next in the list, we have motion excess. Any movement by the team that is not of value to the customer is called motion excess. Repetitive keystrokes, extra walking, sorting, stacking, searching creates inefficiency are all included here. Sources of eliminating this would be to eliminate double data entry by integrating systems, reduce extra motions that lengthen the duration of the task. The last type of waste is found to be excess processing. Any additional steps in a process that do not add value to the customer are called excess processing. Examples for this type of waste would be reformatting, adding extra unneeded features, continuing to do something of low value because it's always been done that way, etc. So, to get rid of this waste, identify what is needed and why, automate, generate and send reports directly out of the system rather than recreating as spreadsheets, remove extra steps that add no value. After knowing about the concepts, Lean and Six Sigma, let us now get to know the combined form of the same, which is popularly known as Lean Six Sigma. Combination of Lean and Six Sigma. According to ASQ, the American Society for Quality, Lean Six Sigma is a fact-based, data-driven philosophy of improvement that values defect prevention over defect detection. It drives customer satisfaction and bottom-line results by reducing variation, waste, and cycle time while promoting the use of work standardization and flow, thereby creating a competitive advantage. It applies anywhere variation and waste exist, and every employee should be involved. To explain in simpler words, Lean Six Sigma is a combination of Lean and Six Sigma. It combines the tools, methods, and principles of Lean and Six Sigma into one popular and powerful methodology for improving your organization's operations. Lean principles help to reduce or eliminate process wastes. Six Sigma focuses on variation, reduction in the process. Thereby, the principles of Lean Six Sigma helps to improve the efficiency and quality of the process, by reducing wastes. Lean Six Sigma's team-oriented approach has proven results in maximizing efficiency and dramatically improving profitability for businesses around the world. After understanding the term Lean Six Sigma, let us point out some of its advantages and get to know the reason why every organization tries to implement this in its system. Benefits of Lean Six Sigma. Lean Six Sigma is one of the continuous improvement methodologies that many companies follow. It impacts the core of an organization's approach to delivering customer outcomes. The benefits of deploying Lean Six Sigma are multifarious, some noteworthy ones captured herein. Let us take a look at benefits for the business and then benefits for the individuals who attain any level of certification in Lean Six Sigma. The first one in the advantages list is simple processes. Lean Six Sigma is one such methodology that simplifies business processes. The cross-functional value stream maps present here will search for those areas of waste and inefficiency. Accordingly, these processes have embedded rework and workarounds for persistent problems. When no wastage is found or a time when no rework and workarounds are required, this is stopped. And the remaining processes are simple and much easier to manage and also to control. This results in a faster process that directly leads to better customer service and higher customer satisfaction. Therefore, it can be proved as a simple and easy process. The next one is talent development. Lean Six Sigma deployment involves every person in the organization to understand the principles and practical application of the techniques. Due to this, an individual gets enhanced with talent development and it embeds learning as a culture within the organization. Growth is found with improved outcomes and continuous learning becomes a part of the organizational culture. Next, in the list of advantages, we have reduces errors and mistakes. Lean Six Sigma starts aiming at quality-based products on what the customers need. This external focus on quality makes the manufacturer prioritize the value of a product to reduce errors and mistakes. Continuous improvement efforts to address these problems also impact business success. In addition to that, the improvement effort on the real problems in the organization will occur. Then, we have quality in business processes. As already told, Lean Six Sigma is a data-driven, decision-making approach. Implementing this from the right first time leads you to improve throughput and an increased transparency. The customer becomes one of the key elements of Six Sigma. A customer's needs with quality delivery ensure that customer voices are continuously heard and product design delivery mechanisms quickly attune to the new market realities. The next advantage is found to be suitable for almost all industries. Although many think that Lean Six Sigma is more suitable for manufacturing and engineering companies. In the last few decades with the application of these principles within other sectors like BFSI, IT and retail. This can prove that Lean Six Sigma techniques have cross-industry application capabilities. The last advantage is improves brand value. Almost every customer trusts those organizations which are able to respond quickly to their challenges in a timely and structured manner and resolve the same with integrity. By implementing Lean Six Sigma, it sets up a good culture of people and a sequence of processes and practices. This in turn helps to build upon this customer success quotient, thereby enhancing brand value further. After getting to know the benefits of Lean Six Sigma, let us directly jump to the topic of various Lean Six Sigma levels. Levels of Lean Six Sigma certification. Lean Six Sigma White Belt certification. White Belt is the first level of the Six Sigma certification process. White belts usually connect with higher tier individuals like a green or black belt. By doing this, they try to solve each and every problem. The main goal of a white belt professional is to understand the basic concepts of Six Sigma. The first level of certification is Lean Six Sigma Yellow Belt certification. Yellow Belt for Six Sigma is where you get to know some simple specific topics, like how Six Sigma is working, what it is, how the disciplines can be applied to the workplace, and many more. A Yellow Belt professional is well known to many basic topics of Lean Six Sigma, which may include the aspects of the phases of DMC. Thus, I recommend that students enter a class to receive the guidance necessary. Yellow Belt Lean Six Sigma is in that stage where the fun is just getting started to eliminate defects from within enterprise systems. The next level of certification is Lean Six Sigma Green Belt certification. A Six Sigma Green Belt professionals usually support a Six Sigma Black Belt by analyzing and solving quality problems. They usually get involved in quality improvement projects. These Green Belt professionals have enough experience to lead and manage a project on their own. But, it also depends on their experience level in that particular area. Green Belts are also known as the workhorses of a business. Because these candidates have a thorough knowledge of the Six Sigma methods and procedures. At this level, they have a distinct advantage when searching for a career. This is because hiring managers seek candidates with the knowledge and expertise those with a Green Belt possess. The average salary for Green Belt starts at $75,000. Next, we have Lean Six Sigma Black Belt certification. Six Sigma Black Belt professionals have the ability to understand Six Sigma philosophies and principles. This may also include some of the supporting systems and tools. This Lean Six Sigma Black Belt professional demonstrates team leadership and understands all aspects of the DMAIC Model Six Sigma principles. Black Belts are also known as agents of change within an organization. On average, these professionals save companies almost $230,000 for every project. The average salary for a black belt is found to be $88,000 per year. Then, we have Lean Six Sigma Master Black Belt. Master Black Belts are at the top level of the chain for Lean Six Sigma. The Master Black Belt, MBB, requirements for individuals are at least 5 years as a Black Belt 6 Sigma, BBSS, or at least experience on a minimum of 10 BBSS projects throughout their experience as a professional. The average salary for these Master Black Belt usually starts at $132,000 and can exceed $200,000 per. Now, after knowing different Six Sigma levels, let us dive into our main topic: Lean Six Sigma Green Belt. Lean Six Sigma Green Belt. As already told you in the earlier section of the video, Lean Six Sigma is a methodology that normally includes information about the basic principles of both Six Sigma and Lean Six Sigma. It is a systematic approach that believes team effort is required to improve performance by removing waste. Lean Six Sigma Green Belt is perfectly suitable for those professionals who want to start their careers in quality management. It provides a proper understanding of process improvement initiatives, under the guidance of a Lean Six Sigma Master Black Belt professional. These professionals are well versed in the fundamental and advanced elements of Lean Six Sigma methodology. They lead improvement projects and also serve as a team member. A Lean Six Sigma Green Belt certified professional required for the organization because they have a clear understanding of all the different phases in the DMAIC method. Attaining this Lean Six Sigma Green Belt certification will surely help every individual by enhancing the skills and thereby enabling me in performing roles like a quality manager, lean manufacturing specialist, lean manufacturing coordinator, quality analyst, etc. Every organization has multiple green belts. The role of these green belt professionals is similar to that of a project leader. These green belt individuals typically work on Lean Six Sigma projects that would fall under their area of expertise and responsibilities. These professionals also know almost all the Lean Six Sigma methodologies and structures. They are also able to apply these lean analysis tools and the statistical techniques commonly used with Six Sigma. After getting to know the Six Sigma Green Belt certification course, let us take a look into what these professionals do. So, what will Six Sigma Green Belt professionals do? The Six Sigma Green Belt is not the subject matter expert for all the processes occurring in the organization, but they often are the expert in some aspect of the process. In general, the Green Belt professionals are not expected to be an expert on all aspects of the advanced Lean Six Sigma tools, techniques and methodologies. If at all they face problems, they turn to their Black Belt for advice and coaching. These professionals start by leading small projects or any other projects that are focused just on one function. Then, most of these Green Belts individuals get involved in improving business processes. The Green Belt is also responsible for ensuring that appropriate Lean Six Sigma tools and techniques are used at each phase of the project. These individuals will also lead the presentation and discussion of the project at the phase gate reviews. Sometimes, these Green Belt professionals may be assigned to a large cross-functional project being led by a Black Belt. After getting to know about the Six Sigma Green Belt professionals' duties, let us take a look into the aspect of who all can take up this certification. Who should take the Lean Six Sigma Green Belt certification course? Lean Six Sigma Green Belt certification is suitable for those professionals who mainly focus on the quality management area. This Six Sigma Green Belt certification is dedicated to those people who want to improve their skills as team members in an organization, or for those employees and organizations who require a standardized approach to problem solving for continuous improvement in quality management. This certificate is suitable for those professionals who want to improve their company's quality through their organization's ability. Process improvement professionals who wish to carry out improvement projects can also take up this certificate. If any management professional is seeking to bring change, their system can also take up this certificate. Or, anyone who wants to be domain independent can take up this certification course. So, what are the job roles that can benefit from Lean Six Sigma Green Belt training? Professionals or any other executives who want to know Six Sigma as a management tool for process and performance improvement at their workplace. Those progressive managers who want to bring change for the better. Quality and process managers, engineers, and executives who need to gain knowledge of Six Sigma and process improvements. Individuals who want to solve business problems using a structured approach. Production managers, production supervisors, and customer service managers. Any professional who is interested in improving his organization's performance. Consultants who want to add the Six Sigma Green Belt in their service offerings and help their customers implement it. Professionals who want to build domain-independent competence. After understanding all these, it is time to know about the Six Sigma course offered by Invensis Learning. About Invensis Learning CSSGB course. Lean Six Sigma Green Belt certification training course is provided by Invensis Learning to develop organization projects by integrating Lean and the DMAIC methodology. Invensis Learning is accredited by IASC and TÜV SÜD to provide live instructor-led online training. This course makes you understand how to measure current performance to identify process issues and formulate solutions. This Lean Six Sigma Green Belt certification training course combines both Six Sigma, which is a methodology to standardize defect measurement and improve processes, and Lean, which is a framework to manage waste. This Lean Six Sigma course focuses on data and size to deliver high-quality products and services to customers. Six Sigma Green Belt certification training's main objective is to provide candidates the knowledge and skills that can enable them to implement Six Sigma methodology to improve projects and processes in their organization. To sit into the CSSGB exam, you must get training from any of the popular sources. Luckily, we at Invensis Learning provide this certification course. But, why choose Invensis Learning? By taking the course with us, you have many additional benefits like Invensis Learning has interactive instructor-led Lean Six Sigma Green Belt certification training with a 99% passing rate. We also have certified trainers with rich domain experience. As already mentioned, Lean Six Sigma Green Belt certification training accredited by IASC and TÜV SÜD. One can also earn 30 PDUs, and training includes the exam cost for Lean Six Sigma Green Belt certification. Along with that, personalized LMS with lifetime access to course resources is available for you. We also have many mock tests to make you confident while appearing for the CSSGB exam. You have a lifetime opportunity to access Lean Six Sigma webinars. Access to case studies prepared by the industry experts is also given to you. Flexibility to retake Lean Six Sigma Green Belt certification training within 2 months is also there. After knowing about the course offered by Invensis Learning, let us see the advantages of this certification course. Benefits of CSSGB. The first advantage is enhance your skills. Being a Green Belt certified professional, you are already equipped with various skills. These skills benefit not only your organization but also your ability. The Six Sigma Green Belt training improves the ability to confidently discuss complex subjects, effectively solve problems, and provide useful recommendations to other team members. The other skills these professionals will gain may include helping in building statistical inference-based decision-making, upskilling you with data-driven problem-solving ability, gaining the skill to make customer-centric actions at every stage, teaching the skill of exploring, analyzing, and solving management problems, enhancing business understanding by teaching the best improving processes, developing the capability to look beyond the present field. The next advantage is found to be lucrative job opportunities in competitive market. Some of the most common positions for Green Belt certified professionals include project managers, manufacturing engineers, process engineers, consultants, and many more. Six Sigma Green Belt certification benefits also include eligibility for multiple industry roles like Lean Six Sigma Consultant, Lead Manufacturing Engineer, Operation Managers, Process Development Engineer, Compliance Structural Engineer Director, Performance Excellence, Reliability Engineer, Business Process Analyst, Continuous Improvement Manager, Operational Excellence Manager, Operating System Specialist, Senior IT Project Manager, Warehouse Operations Manager, Data Scientist, Project Engineer. Then as a next advantage, we have best in industry salaries for all role types. From a career standpoint, glancing through the salaries drawn by different industry professionals for profiles powered by Six Sigma Green Belt certification will prove to you that the Six Sigma Green Belt has many advantages. Six Sigma Black Belt Project Manager earns about $101,954. A Six Sigma Green Belt professional gets an average salary of $76,203. An Operations Manager salary is found to be $66,192. Similarly, a Six Sigma Black Belt Engineer earns about $87,732. Likewise, Six Sigma Yellow Belt professionals earn up to $62,667. A Process Improvement Manager salary is found to be $83,134. Then, the salary for the skill Six Sigma is about $78,085, and for Design Six Sigma is $88,831. Thus, the salary for a Six Sigma Green Belt professional is very challenging, equally rewarding, and can include various job roles. After knowing all the aspects of this Six Sigma course, let us now take a look into the steps taken to gain a Six Sigma Green Belt certificate. How to get a CSSGB certificate. As already discussed, you can take up this Six Sigma Green Belt certification from Invensis Learning. Invensis Learning is accredited by IASSC, so it follows the same pattern as the accredited body. So, let us now look into various aspects of this Six Sigma Green Belt certification. Prerequisites. To attend the IASSC Certified Lean Six Sigma Green Belt exam, there are no prerequisites required. Examination. To sit in IASSC Certified Lean Six Sigma Green Belt exam, one must answer 100 questions. It is a closed-book proctored exam with a duration of 3 hours. In some forms of this exam, the test may also include a few additional non-graded questions, approximately 10. The exam consists of approximately 20 multiple-choice and true or false questions from each major section of the IASSC Lean Six Sigma Green Belt. Also, to achieve the professional designation of IASSC Certified Green Belt from the International Association for Six Sigma Certification, participants must sit for the IASSC Certified Lean Six Sigma Green Belt exam and must get a minimum score of 70%. Now let us see those topics that are taught in the Six Sigma Green Belt certification course. Topics covered in CSSGB course. The topics covered in the IASSC Lean Six Sigma Green Belt training are given below. First, we have Define the Phase, which is covered in 13 hours. This phase has many topics like the basics of Six Sigma, fundamentals, etc. Then, the selection of Six Sigma projects is explained along with the topic of Lean Enterprise. Next, the measuring module is discussed. This is a vast topic that is explained for about 18 hours. Process definition, Six Sigma statistics are discussed here. Also, this module includes measurement system analysis and process capability. The next phase is analysis. Here, the course takes about 15 hours to teach. Here more of the variation is considered. Patterns of variations are discussed along with inferential statistics. Also, hypothesis testing is discussed. The next phase is the simplest one. That is an improved phase with 4 hours of teaching. The topics included here are simple linear regression and multiple linear regression. Then, the couple gets ended with the last phase, controlled with 6 hours of study. Lean controls, statistical process control, and Six Sigma control plans are taught here. So, after seeing the topics covered in the IASSC, now let us start our training video by discussing the same. Each phase has an organizing premise of its own. Once the work is completed, the project can proceed to the next phase. The duration of the phase is purely based upon the information and data that is available. Normally at the end of each phase, there is a phase gate review with the stakeholders and one or more black belts. Let's take a look at each phase in more detail. The first module is Define. Define phase. The Define phase is the first phase of the project. Here, a green belt project leader is selected and provided with a high-level description of the problem. Some yellow belt project team members may also be present. The project team needs to get input from stakeholders and customers to understand the problem from their perspective. During this time, they mainly focus on the aspects that customers consider to be critical quality expectations. The first and second topics can be combined as one topic called Six Sigma Basics. Let us talk about that now. Basics of Six Sigma. Six Sigma is a methodology that gives those who practice it a unique view on processes and people. It is a problem-solving tool and also a terminology to describe the concepts that it uses to improve quality by reducing defects. Even complete strangers to Six Sigma can gain a working knowledge of how the methodology works. They need only develop a basic Six Sigma literacy by becoming acquainted with the fundamentals. To know Six Sigma fundamentals, you must know how Six Sigma can be viewed in various ways and their key elements. Let us discuss those aspects now. Six Sigma can be proposed as some common threads. Let us now talk about that. First, we have Six Sigma as philosophy. Six Sigma views all work as Six Sigma as a process of defining, measuring, analyzing, improving, and controlling the aspects. It just requires input and produces the outputs. If you want a controlled output, you can get it by controlling the inputs. This is generally expressed as y equals fx. Thus, it is a philosophical perspective. Next, we have Six Sigma as a set of tools. Six Sigma uses qualitative and quantitative tools to drive process improvement. These tools include statistical process control, SPC, control charts, failure mode and effects analysis, FMEA and process mapping. Then, we have Six Sigma as a methodology. Most of the time, Six Sigma uses the DMAIC approach for implementing its process is certainly the most widely adopted and recognized. DMAIC defines the steps a Six Sigma practitioner is expected to follow, starting with identifying the problem and ending with the implementation of long-lasting solutions. Last, we have Six Sigma as a metrics. In simple terms, Six Sigma quality performance means 3.4 defects per million opportunities, accounting for a 1.5 sigma shift in the mean. Six Sigma quality is a term generally used to indicate a process is well controlled, within process limits plus or minuses from the center. After understanding the overview of Six Sigma, let us talk about some of the fundamentals of Six Sigma. Let us talk about this by knowing some of the Six Sigma key points. The first key point is: analyze the requirements of customers. Six Sigma means to improve the quality. In other words, it is equally important to know whatever improvement project you are doing, make sure that it is important to your external customer. This is because any improvement project should be aligned with the customer needs, expectation, or satisfaction, critical to quality. The net key point is: target at the mean. Six Sigma looks to achieve the center of the tolerance, compared to being within tolerance. For example, if you are cutting a cloth piece with a dimension of 10 centimeters, then you should be targeting 120 centimeters only, not between 199 centimeters and 121 centimeters. The next one is: reduce defects. Six Sigma emphasizes reducing the defects to the level of 3.4 defects per million opportunities, DPMO. So, one has to ensure to reduce the defects. The last one is: reducing variation. Six Sigma believes in reducing variation. Even though variation is everywhere, but it is the enemy of quality. Quality is related to consistency. Then, in the define phase, we have selecting Lean Six Sigma projects. Project selection is a critical part of the Six Sigma quality improvement process. It is based on objective data rather than subjective guesswork. A project is a sort of problem that requires a solution. A good Six Sigma project is connected to a company's strategic goals and will solve customers' problems. Most organizations can get many project opportunities. But the difficulty is found in sizing and packaging those opportunities to create a meaningful project that is required. To become a successful professional, the project selection process must be well defined and disciplined. One process that has proven successful incorporates a three-step approach. Now let us see the steps included in selecting the project. The first step is to create a team of responsible people to give equal opportunity and work. Then, ask the team to create innovative project ideas. This brings out many outputs for the system. Then, create a structured way of implementing the project, so that no issue can occur in the future regarding the same. Then start implementing those project ideas. Last, in this phase, we have the Lean Enterprise. The Lean Enterprise mainly deals with value creation by eliminating waste, which means those non-essential processes present in the organization. The elements that consumers decide are of a product or a service by consumers. Lean Enterprise is a business term. This term describes the practice of either reducing or eliminating inefficiencies present in the production process. Its main goal is to recognize and increase the value of products or services for customers, whose perspectives and consumer habits ultimately dictate Lean Enterprise directives. After the define phase, next, we have the measure phase. Let us discuss the topics covered in this phase. Measure phase. The measure phase is the second phase in the Lean Six Sigma method. Here, measuring the performance of the process, product, or service with respect to the critical quality is done. Each step in this phase is measured based on time, quality, and many other attributes that were important to the customer's needs. Usually, the perfect measurement system does not exist to collect this data, so a measurement system will need to be developed and verified so that it can provide accurate and complete data. First, in the measure phase, we have process definition. The process is nothing but a series of steps or actions that lead to a desired result or output. To perform a process, a set of common tasks are created for a product, service, process, or plan. Due to this, a customer or group of customers gets satisfied. So, what factors are to be considered while implementing a process? Processes are largely affected by many factors as discussed now. Personnel who operate the processes. Materials that are used as inputs. Machines or equipment that is being used in the process. Methods used in work environment. Understanding how these factors interact and affect processes is a key consideration in process studies. Next, we have Six Sigma statistics. Six Sigma level is a measure of an error rate of a process, based on the DPMO estimate. DPMO means defects per million opportunities. It is a long-term estimate of the process. Six Sigma is represented in a normal or bell curve in statistics, where each interval indicates 1 sigma or 1 standard deviation. As already told, Six Sigma is a statistical term that usually refers to the standard deviation of a process about its mean. In a normally distributed process, 99.73% of measurement will fall within plus or minus 3 sigma and 99.99932% will fall within plus or minus 4.5 sigma. For a process, the sigma capability is a metric that indicates how well that process is performing. In a normally distributed process, if the mean plus or minus 3 sigma range of output is between USL and LSL, then around 99.997% area of the points of the output will be non-defective. In other words, one can say the process is at a 6 sigma level. The 6 refers to the ability to fit the good outputs of the process to fit within 6 standard deviations, or sigmas. Another way to say it is that only 3.4 defects occur per every million opportunities fall outside the control limits. Aiming for 6 sigma level, you have a high probability of producing items that are well within the required specification. Several sigma levels exist, each of which indicates the number of allowed defects per million and thus the level of maturity of a process. Hence, higher the sigma value, the better the process. 6 sigma can also be thought of as a measure of process performance, with 6 sigma being the goal, based on the defects per million. Once the current performance of the process is measured, the goal is to continually improve the sigma level, striving towards 6 sigmas. Then, we have measurement system analysis. Measurement system analysis is an experimental and also mathematical method that determines the percentage of variation that occurred within the measurement with respect to overall process variability. It is an objective method that assesses the validity of a measurement system and thereby minimizes the factors contributing to process variation that is actually stemming from the measurement system. Bias, linearity, stability, repeatability, reproducibility are the 5 parameters that are to be investigated in an MSA. The next topic is process capability. Process capability is a term that is used to measure the relationship between the voice of the process along the voice of the customer, VOC. A capable process can be defined as the one in which almost all measurements of a feature produced by the process fall inside specified limitations. There are several types of indices that are commonly used in this. It can be calculated by taking a ratio of the customer requirement and the expected process variation. Process capability is the ratio of the voice of the customer to the voice of the process. This term explains how well a process performs relative to the VOC. And it is a prediction of how well your process will meet customer requirements in the future. Process capability can be seen in 2 categories. Short-term capability. Here, the potential performance of a process is under control at a point in time. It can be calculated by taking data over a small period of time without any external influence on the process like temperature change, shift change, operator change, etc. Short-term capability represents the true process capability. Long-term capability. Long-term capability is the actual performance of a process over a period of time. It can be calculated by taking data over a period of time long enough such that external factors can influence the process. Long-term capability represents both the technological capability combined with the controls that you exercise. After completing the measure phase, let us move to our next phase, that is, analyze phase. The analyze phase is the 3rd phase of a Lean Six Sigma project. Here, the process and product data are analyzed to determine the true root cause or causes of the problem the customer has experienced. This phase uses lean analytical tools and the Six Sigma statistical hypothesis testing techniques to determine the root cause. Usually, the data collected in the measure phase is more than sufficient for the analysis to take place. However, sometimes, the analysis will point to an area requiring further study and additional data may need to be collected. The first topic covered in this phase is patterns of variation. There are 3 common patterns of variation. The normal pattern is a bell-shaped curve. This is a common pattern of variation. The next pattern is bimodal. This has 2 or more peaks. If something has changed in the process, this will occur. There are some operating differences between shifts, changes occurred in processing methods, temperature and humidity differences are present, equipment differences, raw material changes, or other differences are also there. The net pattern is skewed. This looks like a normal curve pushed over to one side. But unlike bimodal distributions, this non-normal distribution shows the natural variation in the process. If there is a natural upper or lower limit to the data, then it could also show a problem in the process. Then, we have inferential statistics. Inferential statistics is a set of methods that are used for drawing either conclusions or inferences regarding characteristics of the populations, which is based on data from a collected sample. This statistical inference's main objective is to draw conclusions about population characteristics based on the sample's information. Inferential statistics allow a person to make inferences about a population on the basis of data collected. The inference and a measure of its validity are the two elements of inference. The last topic covered in this topic is hypothesis testing. Hypothesis testing uses statistical analysis for determining if the observed differences between two or more samples are from what kind of random chance or to true differences in the samples. In simpler words, it tells us whether there exists a statistically significant difference between the datasets required to consider that they represent different distributions. From a practical point, finding statistical evidence that the null hypothesis is false allows you to reject the null hypothesis and accept the alternate hypothesis. Steps to be followed in hypothesis testing are: first, one must determine an appropriate hypothesis test. Then, state the null hypothesis HO and alternate hypothesis HA. Soon after calculating the test statistics, then, interpret the results. After this phase, we have improve phase. The improve phase is the fourth phase of a Lean Six Sigma project. Here, team members create a solution to the problem that eliminates or contains it. Depending on the nature of the problem identified, various team members will play accordingly by giving a larger or smaller role in the creation of the solution. In this improvement phase, the solution is developed appropriately and then tested. This may become the most expensive phase depending upon the nature of the solution. This is often the most expensive phase. But by the end of this phase, the solution is prepared by the team members. The first topic in this phase is simple linear regression. Linear regression is a mathematical term that measures the relationship between two variables. In context to Six Sigma, these are usually variables in a business process. In simpler words, linear regression is a statistical technique that is used to estimate the mathematical relationship between a dependent variable which is usually denoted as y and an independent variable which is usually denoted as x. In other words, predicting the changes in the dependent variable is done according to the change in the independent variable. For example, when conducting an analysis, linear regression is a simple tool employers use to locate the cause of errors. The next topic is found to be multiple linear regression. Multiple linear regression is just an extension of a simple linear regression methodology that we discussed just now. As already told, simple linear regression is to study the two variables in which one variable is an independent variable x, and the other one is a dependent variable y. In other words, predict the change in the dependent variable according to change in an independent variable. While multiple regression is used to build a model that allows us to study this interplay. Multiple regression-based models will use the data to create a function that predicts the outcome based on the independent variables. This model is built using, for example, a set of real-world data listing the outcome in various cases. The model can then be used to predict the outcome given a set of independent variables or find out how well the existing data fits the model and if there are any outliers. Now lest we move to our last topic, that is control phase. The control phase is the final phase of a Lean Six Sigma project. Here, the solution is implemented completely. This control phase will not get completed till the solution is stable in all aspects of the business, and until that does not create any changes to the operation. Every member present in the project team gets involved with this implementation so that even small changes required to their departments are fully implemented. In simpler words, this phase continues until the process has demonstrated stability in its performance. This phase may take a few days or sometimes may also take several months too. So, a control plan is always set in place for monitoring the process, product, or service. This phase is completed only when the operators and managers of the process no longer require support from the project team. The first topic covered under this phase is lean controls. According to James Womack, lean control is a process for measuring and reducing inventory and streamlining production. It is a means for changing the way a company measures plant performance. It is a knowledge-based system. It takes years of hard work, preparation, and support from upper management. Lean is so named because it purports to use much less of certain resources, space, inventory, workers, etc., that is used by normal mass production systems to produce comparable output. Lean control is a great example of non-financial controls in action. This is used in improving the quality of products and services and thus decreases waste. Researchers say that up to 70% of manufacturing firms use some form of lean in their business operations. The next topic is Six Sigma control plans. A control plan is one of the methods for documenting the functional elements of quality control that are to be implemented to ensure that quality standards are met for a particular product or service. The control plans intend to formalize and document the system of control that will be utilized. The main intention of a process control plan is to control the product characteristics and the associated process variables to ensure the product's capability and stability over time. The last topic is statistical process control. Statistical process control is a process improvement methodology. This method is usually used to monitor, control, and continuously optimize a process. In other words, SPC is a method of quality control that employs statistical methods to measure, monitor, and control a process. It is used to improve the process by eliminating special cause variation in a process. SPC can also be used to analyze and control process performance, proactively control processes, distinguish between natural and assignable variations, identify and prevent processes from special causes, and involve the use of control charts to determine if a process is operating in control. Well, this becomes our last topic. The topic discussed till now is for Lean Six Sigma Green Belt professionals. All the topics explained here are not that brief. If you want to know more about all these, then you have to take up the Lean Six Sigma Green certification from us. By this, you can understand the concepts in broader aspects. If you think I have missed anything in this video, please mention it in the comments section. Thank you.